in this one, I'm just going to double check that everyone is cool with plugging numbers in. This is just a plug and chug. The way this might be phrased, and again, this is for first order. There are other versions that are second order or zero order. You would just use the equation they give you, but I'm just showing you about filling it in and plugging it in. This right here is specific to a first order. So what is the half-life? So if initially there are 50 grams, and after 500 hours, there are 1.5 grams. So you'll notice that the amount became less, right? So we would say the natural log of, this is A of t, because that's after a period of time. It's gone down. This is A, and that 0 means at time equals 0. But we often say A original or A initial, but that's at time equals 0. That's how much there was at the beginning, basically. So we just put 1.5 grams over 5.0 grams equals negative k times, and then we know t is 500 hours. And so we can solve for k, and the reason we're solving for k is then we're going to plug it into this and solve for t1/2. So I'm going to go ahead and write it as ln of 1.5 over 5.0 divided by 500 equals, and I'm going to bring the negative over here, k. So negative ln of 1.5 divided by 5 divided by 500. So you can see that my k value is 0.12241. So that's my k value, and if I want to know my t1/2, then I take 0.693 divided by 0.00241. Notice that that is in, like, the way that this works is that this is unitless, but this came over in years, but it's in the denominator. So the unit for that is inverse years. It just means per year is what it means. So when I take that, I'm going to say 0.693 divided by second answer, and I'm going to get that my t1/2 is equal to 200, and remember this was inverse years, and this is unitless. So when you divide by an inverse, you end up with it being on top, like this is years to the -1. So divided by years, you end up with 288 years, or my t1/2. Now, someone might say, hey, but I want it in seconds. Don't forget that you can take your 200 years, and then you can go in 1 year, there are 365 days, and then in 1 day, there are 24 hours, and in 1 hour, there are 60 minutes, and then in 1 minute, there are 60 seconds. So you can do that math if someone wanted the t1/2 in a different unit. That's kind of an example of plug and chug and how to go about solving it. Of course, there are going to be different equations depending on what order it is. This is the most common one, and this is the one that you would be using in the radiochemistry chapter. So this one definitely is going to come back, and so you'll have experience with it.